and the 1, which is a 6, as selling price needs to be larger than the buying price. I don't think that's correct. I think what they mean to say there is that you can't sell before you buy. Example 2, which is just a steady declining of 7, 6, 4, 3, 1. The output for that is 0 because there's no time that you can buy lower than you can sell high. This stock is just going down, down, down in price, kind of like Snapchat. Topical. So let's think about the approach. And as we see over here, we have 7, 1, 5, 3, 6, 4, which is their first example. And as we hop through this problem, you're going to think about, okay, what quickest time complexity and what space complexity am I going to try to see? And when you see like problems like this, you're eventually going to figure out, okay, well, one, it's a Leetcode easy. So that tells you something right there. But this is a list problem. You shouldn't have to walk through the list more than once or nest anything. So you should be able to get a time complexity of linear time complexity or O of n, and a space complexity that's constant space complexity, just storing a few variables, nothing major, no large data structures. So with that in mind, one approach is, as we walk through, the 0th element is 7, and then the first element is 1. So we're not going to try to buy the 7, because that's the highest actually that we see it at any time, but we're going to want to buy the 1. And once we get to the second element, from the first to the second, we can see we have a 5. So okay, well that's one possibility. Selling 5 and buying 1 and selling 5 when we get 4. And that's interesting. When we get to the third element, well, the difference between the 5 and the 3, that's -2. So we're not going to try to buy 1 and sell 3. But once we get to the fourth, we want to say, oh, well, if I buy 1 and sell 6, then I make 5. And it's a bit of a leap, but there's an algorithm called Kadane's algorithm, which uses a max. I take one swig of water, and we take a like a running max or a max to here is, I think it's how it's originally described in the paper. And we have like a max so far, or like a total max. And so a max to here would say, okay, well, between 1 and 5, I have a max to here of the second element of 4. And then once I get to the third element, the max to here is then only 2. So with Kadane's algorithm, the max to here, it's going to be between a max of itself, a max to here, as well as 0. And that's to take care of situations where we never want to buy this 7 and sell 1. We want to buy low, sell high, right? That's the whole idea. And the 0 will go ahead and take care of that. It'll reset the algorithm to a 0 if you only had a negative possibility up until that point. And with that, the second max is a max so far. It's like a running max. So if we have a 1 to 5, well, then the max to here is 4. And then 1 to 3, then the max to here becomes 2. But the max, if you have a max so far, which is a max of itself, as well as the max to here that you've seen so far, well, then you can keep that in mind. So when you get to this from 1 to 6, then you're comparing a 5 to a 4, and then the max so far becomes a new max so far that you can eventually return. This sounds a little confusing. I think it'll be a little bit easier once we put pen to paper. That's the approach for Kadane's algorithm. One thing you have to think about inputs. One of the gotchas for this question, it's got 200 test conditions, is if you're given a blank array or a prices list that has no length, you want to go ahead and return 0. You don't want to be able to error out on that. So that's the first thing we're going to say is if the length of the price equals 0, then we want to return 0. And then those two maxes that we talked about before, we're going to go ahead and instantiate those. So we have a max to here, which is going to be 0, and a max so far, which is also going to be 0. Then we're going to instantiate a for loop for I in X range, because this is Python 2, so X range a little bit quicker. Python 3, you're not going to use that. We're going to start at the first element of the array or list in Python, because we're going to be making comparisons backwards. The prices of I compared to the prices of I minus 1. If we started at the 0th element, we'd get an out of bounds error. So we're going to start at 1, and then we're going to do length of prices. So then we're going to walk through all the elements and make comparisons. So that max to here that we talked about, that's simply going to be, like we said, a max of 0. Like we said, we want to, if we start at that 7, we want to be able to start again with a max to here of 0 at that 1. And then it's going to be with itself with the change. So the prices of I minus prices of I minus 1. So that'll be the change from element to element. So from 1 to 5, that'll be a 4. So the max to here will become a 4 there. And then we have a max so far, which just kind of maintains that memory. It's a max of itself, and it's a max of the most recent max to here. So we want to compare that. And then at the end of the day, we want to return that max so far. So the custom test case is the same thing. And I think it might be useful, and we got a little bit of time, to just print max to here, as well as the variable itself, and the print of max so far as we walk through this list. So let's go ahead and run that code. A compile error. Invalid syntax on line 16. Commas are always nice, aren't they? Hopefully that's it. So I probably also should have printed it out as 0. But as you can see, our answer is the expected answer, which is always good to see. The max to here starts off as 0. At this second jump, it becomes 4, and then the max so far also becomes that 4, as you see here. Then the max so far jumps down to 2 because we're only comparing between 1 and 3. But the max so far, assuming that's the max to here, the max so far maintains that 4. Then the max to here becomes a 5 because it's going from 1 to 6, and the max so far retains that. And then even though we finish on the max to here of 3, we maintain that max so far of 5. So let's go ahead and submit the solution. Let's see if it passes all the test cases. And time limit exceeded. Oh, because print statements aren't so optimal, are they? When we do our pull request, we usually try to remove those. So we saw it failed on a very large input. And judging, and it's accepted. It's generally been doing around the 30th percentile. This one's only 10th. I'm not sure. I think that's just finding the system in a weird state. So this is something that works. We use the 2 maxes, but I think a different approach to this problem of buying once and selling once and buying before you sell. If we think about the concept of a min price, that's really all we're doing, right? We want to compare a min price to where we currently are. And I think that's a little bit easier to think about than a max to here and a max so far. And so this algorithm that we're going to do right now is going to be the same time complexity, going to be the same space complexity. But it's easier, the space complexity that takes up in your brain, I think it's a little bit easier to think about. So basically, as we walk through, we want to say, okay, what's the min price? I can set the min price as the 0th element of the array. And as I walk through from the first element on through the array, if my price, the current price I'm looking at is lower than my min price, then I want to set a new min price. Otherwise, I want to make that comparison. So after the first element, I want to change that to a 1. Otherwise, I want to make that comparison, and I want to set a new max profit. So I want to look at the difference between the min price and that. And so this is the same general concept as Kadane's algorithm, I think. It's still linear time complexity, but still it's easier for me to think about. So let's go ahead and just walk through that as well. So we still have that same corner cases. If we have an empty list, we want to return 0. And now we have to set a min price. I'm a fan of setting it to be the first thing in the array or list if we're dealing in Python. Sometimes you can see people set min prices as really high numbers like system max int. If we're given an array with numbers that we know are valid, I like to set it as the first one, and then, or I should say 0th index, and then walk from the first index on. To me, that's a little bit cleaner. The max profit, as stated before, in this case, if no transaction is done, the max profit is 0. So we want to have that. So our for loop looks exactly the same. And what are we going to do now? So basically, there's two conditions. If what we're currently looking at is less than the min price, then we set a new min price. And this is a very, very common piece of code that you see. Something like this. You see there's a max as well. So the min price will be the prices of I. Otherwise, we want to make that comparison, right? So then we take a look at where we currently are. And we say, all right, the max profit, that's going to be the max of the max profit. So we retain that memory of larger profits that we saw in the past. Or it could be simply just the difference of where we are and the min price. That's it. And so with that one, I don't think it's really worth doing a custom test case. We'll just go ahead and submit the solution. And we got a wrong answer immediately. That's because I said return min price. So when you kind of barrel along and you don't actually test your code, that will get you. I just got gotten. And I know I'm going to get got, but I'm going to get mine more than I get got though. So I'm going to return the max profit right there. And then I'm going to go ahead and submit the solution again. So returning things are very important. So that's one way. This beat 98% of Python submissions. I think that's a bit of a fluke. Before I was testing it, it seemed to be about on par. It is the same time complexity as Kadane's algorithm that we just did beforehand. And once again, it's just setting a min price and then just making comparisons as we walk along. I'm just going to take one brief moment before I hop into the next section. One moment. All right, let's hop into the next section. So this was Leetcode 121, best time to buy and sell stock. And now we're going to jump into Leetcode 122, best time to buy and sell stock 2. So before we were only buying and selling once and buying before we sell. But now let's go ahead and read the problem. Say you have an array for which the ith element is the price of a given stock on day I. Design an algorithm to find the max profit. You may complete as many transactions as you like, i.e. buy one and sell one share of the stock multiple times. However, you may not engage in multiple transactions at the same time. You must sell the stock before you buy again. So this one, I like this one because it sounds very complex. It's once again a Leetcode easy. And one thing that's kind of funny to look at, if you look at the likes here, it's got a lot of dislikes and only a few likes. Oop. Hello, Pulsating. Thanks for stopping in today. And this previous one of 121, best time to buy and sell stock, has a lot more likes, only 16 dislikes. So why is that the case? And I think the big reason is that this is, I think, like a gotcha question. It's hard to say what a gotcha question is, but like it's one where the solution becomes very obvious once you know, and it's very, very easy to regurgitate that. Yeah. So I'm going to just kind of walk through. So we want to buy and sell as many times as possible, but we can't buy and sell at the same time. So if we think about that, we can, so we would still not buy at 7. Let me switch the old view, check that. So we would still not buy at 7, but we would buy at 1 and sell at 5, then buy at 3 and sell at 6. So we'd make a total of 7. And then also, what happens here? If we go between 4, 5, and 6, let's say we extended our array or list in Python. Well, you would want to buy at this 4 again, and then sell at this 6 to capture 2. You wouldn't want to buy at 4 and then sell at 5 and then buy at 5 and sell at 6 because you can't do that. You still want to capture this 2 because you buy here and then you sell here. So this problem, it's like, ooh, this sounds very difficult. This sounds very interesting. This sounds a lot more difficult than the previous question, but actually it's a lot easier. And the reason for that is, well, think about it. You're buying and selling, and that's not a very helpful statement, but think about it. If you're buying and selling, and you can't buy and sell at the same time, well, you're not actually buying and selling, right? You're just like looking at the difference, and that's the key to this problem. If there is a positive difference, you want to capture that because it will be captured. So what does that mean? So if there is a positive difference between 1 and 5, yes, you want to add that to your max profit. And if there's a positive difference between 3 and 6, you want to add that to your max profit. But not only that, between this 4 and 5 and 5 and 6, you want to add each of those elements to your max profit. And the reason for that is at each individual step. Because say this 4 went up to 5, and then it went down to it went down to 3. Well, because you know the entire thing, you can buy and sell as many times as possible, you're still going to capture this 1. Now let's say this 5 went up to this 6. Or let's say it went up to an 8. Well, you're going to buy at 4 and sell at 6 or sell at 8. But you're still going to capture this 1. And so from this jump to this next, from this 5th element to the 6, you're still going to capture that if it's positive. And so with that, we have everything we need to know. And this is a very simple algorithm and probably why a lot of people dislike this algorithm, because all it is going to be, and actually I don't even think it checks if the length of prices is 0, but we'll go ahead and check that again. But we're going to say, let me just think 1 second. We're going to do a max profit is equal to 0, and a very familiar for loop from here. We still want to capture that first element, that 0th element, so I was thinking about that. So basically all we want to say is if what I'm currently looking at, if there's a difference that's positive, I want to update my max profit with that difference, because it doesn't matter if I'm going to actually sell at that next point, but that difference is going to be captured. So the max profit is going to be plus equals that difference. And I'll just put this on another line to make it a little bit more readable. Not I plus 1. The max profit will be the difference of prices of I minus prices of I minus 1. And then we're going to just return the max profit. That's all there is. We're buying and selling multiple times, but the algorithm is much easier to write. So I'm just going to run a test case. With empty input, we get 0. Expected answer is 0. And in Leetcode, you can give it like this. So if we do just like we wrote, 715, 3, 6, 4, 5, 6. So this should be, we capture the difference between the 1 and the 5, that's 4. The difference between 3 and 6 is 3, so that's 7. And between the 4 and the 6 is 2, so that's a 9. So if we run this code, we should see a 9. And let's go ahead and see. Expected answer is 9, and my answer is minus 1. So let's see if we can debug this supposedly easier one. For I in an X range of 1, length of prices, if prices of I, this greater than a 0, that's very important. Otherwise, that's not what I described. Otherwise, we were just looking at the difference between the last two elements, basically, because we were just taking it, like adding up as we go along. And we see that our answer is a 9 overall. So we go ahead and submit the solution. Let's see if we pass all the test cases after making that quick little bug fix, and we do see that it's accepted. I like this problem a lot because one of the top rated answers on Leetcode says, is this question a joke? A simple code like this, designer of this question must have thought of something too complicated. And yes and no, especially going from the first one to the second one. I think it's easy to like think about something that's very complicated. I like this question a lot though, and I don't think it's quite a joke. It still is Leetcode easy, so a little bit on the easier side of Leetcode, but it's still a way you can get very confused very quickly on this type of problem. And you can, but if you take a step back and you think about what do I actually need, and you write actually what you need with a good, and what's the difference, then it's a lot simpler, and then it kind of becomes okay. This is very important. So yeah, that's about all we're gonna have today. This is Programmer Mitch signing out. Yeah, that was 2 Leetcode easies. Best time to buy and sell stock 2 and best time to buy and sell stock 1. Yeah, I think I like this format. On most days, I think I'll try to do either 2 Leetcode easies or equivalent, or 1 Leetcode medium, as well as, or 1 Leetcode hard. But the easies we can kind of go through quickly and get a good understanding of those. So with that, this is Programmer Mitch signing out. I hope to see you next week every Sunday at 6:30 p.m. Walking through data structures and algorithms questions in Python for interview prep, as well as just learning data structures and algorithm questions. So I have a little bit of time left, and I've been watching Hot Ones. And so they pimp out on their Blair's, I'll just kind of show over here, Blair's original death sauce with Chipotle. It's 30,000 Scoville. And yeah, I tried it out. It's not super duper spicy, which was something kind of interesting to do. I'm trying to get to like the Hot Ones challenge. I want to get up all the way to the really hot ones that they have and not kind of flame out. And I like this. This kind of tastes good. If you've had the Chipotle Tabasco sauce, it feels like that, but just like twice as spicy maybe, and it's pretty good. So I've been, if you haven't seen Hot Ones, the fellow interviews people as they have spicy wings, and they get spicier and spicier. And I'm kind of doing like a personal Hot Ones challenge. Coder Eli says, "Don't use that." Why is that the case? Is it not good for you? Is it going to cause my death? I'll just wait. I have the delay turned all the way down, but unfortunately, it's still kind of slow. Too spicy? It's kind of spicy. It's like 30. It's 30,000. It's not too bad. It might be bad if you have IBS though. Anyway, this is Programmer Mitch signing out. Until next time at 6:30 p.m. on Sunday. I'll catch you later.